picking up where we left off. So A is your initial amount in your exponential function, or your starting amount, starting value. B is your growth rate. The exponent, what makes it exponential is that it has an x in the exponent spot. So linear function, y equals mx plus b. The x is part of the equation. We have a slope, we have a starting value. But exponential, the x, the unknown, is the exponent itself. So just visually, that is how you want to tell that. So moving on and working on a couple word problems just to identify which type of function it is. So linear versus exponential. A gym's customers must pay $50 for a membership plus $3 for each time they use the gym. What do you think? So it says they must pay 50, so that's definitely going to be our starting amount. And then $3 for each time. This is going to be a linear function. We should be able to write these very easily. So 3 for each, that's going to be our rate of change. With our starting initial value, or the amount you have to pay no matter what, is going to be 50. So you must pay the non-negotiable starting amount. The thing that changes is your $3 for each. Number 2, there are 20,000 owls in the wild. Every decade, the number of owls is halved. So 20,000 in the wild. Every decade, the number of owls is half. So every 10 years, it's going to be half that much. So that means we know we start with 20,000. That's our initial value, so that's our A. Then we need a B, and that B value is the number of owls is halved. So that means that's going to be times 1/2 per 10 years. So we could put an X here. But remember, if we have to solve this later to make sure we know that that does say 10 years. Decade is 10 years. Every decade is 10 years. And that's just back to that we've talked about, making sure you're paying attention to the units of measurement in the word problem, and then versus the question, or on the table or graph versus the question that's being asked. So our initial amount is 20,000. Our rate of change, or our growth rate, is 1/2. It's decaying. So this is decaying because they're getting smaller, right? Decaying because it's getting less. It's less than 1. Half is less than 1. A library has 8,000 books and is adding 500 books each year. So each year, hopefully you know, is your MX. And so we start with 8,000. So this again is linear. If we write that equation, 500 each year on top of the 8,000 they started with. So that is definitely going to be a positive linear equation because that 500 is positive. At the carnival, you have 50 ride tickets. Each time you ride the roller coaster, you will pay 6 tickets. So in this case, it's again, each time you ride the roller coaster, you will pay the same amount, 6 tickets. So if I have 50 tickets, it's my starting amount, right? And then I'm going to lose 6 tickets every time I ride a roller coaster. So it's a negative linear function at that point. It's going down by 6 every time you ride the roller coaster. A bank account starts with $10 every month. The amount of money in the account is tripled. Okay, so that's not each time. That's not per whatever. It's the amount of money is tripled. Tripled is a 3. So hopefully that to you does not sound like our linear equations we've been working with. So we have our A, so our starting amount times the amount it changes, and then to our exponent. That's how we're going to write our exponential function at this point. So we're going to start with $10. We're going to triple it, so multiply it by 3 every year. Or every month, I'm sorry, every month. So again, this is another one of those every month, not every year. So if it says, how much money do you have in 1 year? You don't want to put a 1 in the X. You want to put a 12 because there's 12 months in a year. So make sure we're paying attention to our words for our word problems. We're going to practice lots of word problems. But noting that it is not per the same amount per day added. It is actually that it is tripling or doubling, or that it is multiplying by a percentage. Number 6, as a reward, you ask for a penny the first day and to double, ding, 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 the amount each day for 30 days. So that means we're going to start with a penny. Double is a 2, so we're going to multiply it by 2 for however many sets of 30 days, right? So if we did it for the first day and then to double the amount each day for 30 days, that's every day. So we would put a 30 in the place of X there if we wanted to know how much money we had at the end of that. So you're starting being 1 penny, that doubles every day for 30 days. So we could put 30 in the X, and then we would know our amount of money if you wanted to solve this guy. But noting that that is not a linear function, it is an exponential function. Your starting value being your penny, and then the rate of change or growth being that double, the 2. All right, so graphically, what a linear function looks like versus an exponential function. So linear function, straight line. We have our y-intercept at 0. So we know 0, 0 is our starting point. It looks like it goes up 1, 2, and over 1. So our rate of change, so our b value is 0. Our rate of change is 2 over 1. So this function will be y equals 2x plus 0. So it is a linear function, and it goes up 2 over 1. It does the same thing here, up 2 over 1. So a constant rate of change being an addition of 2. So then if we look at our function below it, that's our add 2, add 2, add 2, add 2. I will say be careful, because EOC style questions, we want to make sure this side is a 1. Because if this side is not a 1, remember, rate of change or slope is the differences in y's over the differences in x's. So if this is not a 1, that would change. But in this case, it is indeed 2 over 1. So we're adding 2 all the way down. Linear, consistent addition or subtraction from a table all the way down. All right, so exponential is a little bit of a, I like to call it like a half pipe. If you think about skateboards or roller skating, half pipe. It's not a parabola. It's not a big U. It's just, and it's definitely not linear. There is a slight curve. So in this case, this is positive. So to our previous notes, that means this is going to be growth. This is going to be a growth exponential function, because it is not linear, because it does not make a straight line. Also, in the table, we are still going 1. We want to check 1 to 1 to 1. So the x values is up 1 every time, plus 1. But this is not an addition of 25 cents. So like if we wanted to check it, so that's add 25. That's not. That's add 50, right? And that's add $1. And that's add $2. So that's add 25 cents. Still not getting there, right? But we should see that these numbers are doubling. So 25 cents to 50 cents is times 2. 50 cents times to $1 is times 2. $1 times 2 is 2. 2 times 2 is 4. And I'm saying dollars because of the decimals, just because most of us speak money better than decimals and fractions. So because this is multiplication by 2 all the way down, then you will see that it is an exponential function in your table. So if we look at our tables below, we have 5 of them. We're going to check them. So you're going to check your x values first, always. So 0 to 1 is 1, 1, 1, 1, 1, 1, 1. So we don't have to worry about the x portion of our rise and run, whether it be linear or exponential, just in general. So it is a 1. So it's going to be some number over 1 for our rate of change. 2 to 5 is plus 3. 5 to 8 is plus 3. 8 to 11 is plus 3. And you do want to check it all the way through. These are all plus 3. So hopefully you know that since it does indeed mean plus 3, this is going to be a linear function. Now, you can either go to your calculator and put in x and y into a table and get a linear function, a linear regression, a linear function. And you would get and you've learned how to do that in Desmos already. You've learned how to do it in your calculator, hopefully already. Or wherever you see x is 0, remember, this is always your y-intercept, your starting point. Your initial value is what is the number when x is 0. So from here, I know my slope is 3, and I know my starting amount is 2. So my equation, we could write it quite simply as y equals 3x, because my rate of change is plus 3, and then plus 2, because that's where x is 0. So that would be that linear function. So this one is indeed linear because it is consistent addition of 3 all the way through. B, I challenge you to pause your video right now. See if you can figure this one out first. If not, hang tight. We'll do it together. Check your x first. Plus 1, plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. So everybody's there, so that's perfect. So it's going to be over 1. And I'm sorry, back to the other one. That's 3 over 1. So 3 to 6 is add 3. 6 to 12 is add 6. That's not going to be good, right? Because that's not the same. So you can basically stop right there. You know it's not linear. And in this case, you only have 2 choices. It's exponential. But if you had more choices, you want to check either way and just make sure it works all the way through. Plus, we have to figure out what our rate of change is, even though we know it's not linear. We know it's exponential. How did I get from 3 to 6? I multiplied by 2. 6 to 12. All right, it's multiplied by 2. 12 to 24. Again, multiplied by 2. Perfect. Multiply by 2. 2, 2, and 2. And multiply by 2, the word you're going to see is usually doubled. If it was multiplied by 3, it's going to be tripled, quadrupled, All those fun things are going to be words you're going to need to know. So multiplied by 2 would be doubled. So we know that our initial amount, again, where's x, 0, that y value, that's our a value, so that's going to be 3. And then we're going to multiply it, because it's going to double for some amount of time. That x has to be above. It cannot be straight across. It has to be as in an exponent spot. So as a superscript up in the top. So subscript over the top. Look at the next one again. Pause your video. Nothing ventured, nothing gained. If you don't try, you don't know. So 10 to 5 is minus 5. 5 to 2.5 is not minus 5. So we know linear is out. So we got to figure out how do we go all the way down. So this one is decreasing, though, for sure. It's definitely not increasing because 5 is less than 10. $2.50 is less than $5. So to get from 5 is half of 10, right? So we either multiplied by 1/2, which is the same thing as dividing by 2. So multiplying by 1/2 is the same thing as dividing by 2. So we're going to multiply by 1/2. We're going to multiply half because, again, $2.50 is half of $5. $1.25 is 1/2 of $2.50. 62.5 cents or 0.625 cents is half of $1.25. And this is one of those things you just want to check it in your calculator and know that it goes down by 1/2. And again, please don't assume, because as soon as you assume, there's going to be one that's off. And then in that point, it's a scatter plot. It is not an exponential function. It is a regression. We could force it into it like we did last when we were doing our linear regressions from our scatter plots. But you want to make sure it's consistent all the way through. So it's going to be 1/2. So our starting amount, again, where is 0? X 0. Y is going to be 10. So our starting amount is 10. We're going to multiply by 1/2. And you can put 1/2 as a fraction, or you can put 0.5 because it is going to half. And then it has an x in the exponent for however long we should want to track it. And that table shows us that if we track it for 6, then we have 0.15625. If we tracked it for 2, then it would be 2.5. So it shows you your table and above, and now we have our function. Again, you can also put this in your calculator, and there is an exponential regression option to get these functions as well, which I will show you tomorrow. Right now, we want to be able to identify it from a table. All right, so looking at this guy, so from 12 to 8, I subtracted 4. 8 to 4, I subtracted 4. Oh boy, looking good, looking linear. Minus 4, minus 4 again, minus 4, minus 4. Make sure your x's are 1. So 1, 2, 3, 4, 5, 6, 7. So that is plus 1 all the way across. So in this case, it is going to be linear. And our rate of change is a -4. I want you to tell me what the b value is, which means that it's where x is 0. So here it's going to be y equals -4x plus 12. So this is a negative function because it is going, or a decreasing linear function, just like the one prior was a decay exponential function because things are getting smaller. And it still is the same process. If you're looking at your y values, are they getting bigger or are they getting smaller as the x value gets larger? As the x value gets larger. All right, one more. So 50 to 35. 35 to 24. Hopefully you see that that in itself is not a consistent decrease. I personally don't know what that decrease is. So we're going to take our calculator and figure that out. You're going to use Desmo's calculator on your phone, calculator, whatever kind of calculator you have. So it's going to be 50 divided by 35 is 1.42. So 35 divided by 24.5 is 1.42. 24.5 divided by 17.15, because that's the next one, is 1.42, and we're going to call it 1.43, just for the conversation. So this is a multiplication. It's going to be a fraction. So let's actually turn to a fraction. Math, frac, 10 over 7. So 7, it's going to be a messy number. So we're going to multiply that by, or divide it by 1.43 is our, we know this is exponential. So let's divide by 1.43. So 50, and if you want to check yourself, divide by 1.43 should give me 35. Indeed, it does. And again, we rounded, so it's not going to be perfect, 1.43. And it's division because we're getting smaller, so we're starting to cut down in this case. So we're dividing by 1.43. which is the same as dividing by 10 over 7. These numbers are getting smaller. It's decreasing at a rate of